Hello, how was everyone? I hope you're doing well. Hope you guys enjoyed your holiday on Monday. So this video is for class for my Tuesday, Thursday class on January 19th, and then my Monday, Wednesday class, Wednesday the 20th. I sent you one PowerPoint and one practice sheet that should last for 2 full class periods. And then I'll tell you which slide we're going to start on for our next class. All right, so let's go ahead and get started. So your first unit for this, or section for this evening, is 2.1a, linear equations in one variable. A linear equation in one variable, say the variable x, is an equation that can be transformed into the form a times x plus b is equal to 0, where a and b are real numbers and a does not equal 0. Such equations are also called first-degree equations, as x appears to the first power. In other words, if you don't see an exponent, that means the exponent is 1. So when we're talking about linear equations, our variables only have an exponent of 1, which of course, when it's written that way, you don't actually see the exponent. So let's just quickly review some problems that you would have had in high school. Letter A and B, these are both two-step equations. So for all equations, your goal is to get your variable on one side of the equal sign by itself. So we want the final line to say x is equal to a number. So what we're going to do is get everything that is on the side with the variable, we want to get it to the other side, or in other words, we want to cancel it out. So I see a times 5 with x and a plus 7. So when you solve equations, you're going to do the opposite of what is happening. So you start with plus and minus when you're solving equations. So the opposite of plus 7 is minus 7. So I drew that line because everything I write on one side of the line, I have to write on the other side. Everything I do on one side of the equal sign, I have to do on the other side. So now what do I have? I bring down my 5x. I got rid of plus 7 because 7 minus 7 is 0. And on the right side of my equal sign, 22 minus 7 is 15. Bring down that equal sign. And now this is 5 times x. So the opposite of multiplying by 5, I'm going to divide both sides by 5. So 5 divided by 5 is 1, and 1 times x is x. So 15 divided by 5 is equal to 3. And that is what my variable x equals. So to check my answer, I can always plug 3 back into the equation. So 5 times 3 is 15. And does 15 plus 7 equal 21? Yes. So I know my equation is correct. Letter B, same thing, except that I have to use the distributive property. I have to multiply everything in my parentheses times 4 before I'm allowed to start doing the opposite operation. So 4 times 3x is 12x. 4 times 2 is 8. Bring everything else down. Now I want 12 by itself. So I'm going to first get rid of plus 8. So the opposite of plus 8 is minus 8. So I bring down what I have left. So I have 12x. 8 minus 8 is 0, so that's gone. And then 68 minus 8 is 60. And then I see 12 times x. So I'm going to do the opposite. I'm going to divide both sides by 12. 12 divided by 12 is 1. 1 times x is equal to 5. So then I can plug this back in to make sure I have my right answer. So 3 times 5 is 15. 15 plus 2 is 17. And is 4 times 17 68? Yes, it is. So I know my answer is correct. All right, so we're going to move on. So these types of equations have exactly one solution that makes the equation true, but that's not the only type of answer you're always going to get. So sometimes we're going to find out that we have no solution to our equation. just like the last two examples, there's exactly one solution to make the equation true. And in some situations, we're going to find that the variable x, or whatever your variable is, has an infinite number of solutions. So let's look at those types of problems. So if you notice, there are variables on both sides of my equal sign. So the first thing I got to do is get rid of these parentheses by distributing everything in the parentheses by 5. So I'm going to bring down what's on the left side of the equal sign exactly like I see it. On the right side, I'm distributing 5 times x is 5 times w is 5w. 5 times 5 is 25, and I'm going to bring down my minus 20. So now I have like terms right here. I have a positive 25 minus 20. So the next step is combining like terms. So you can't combine across an equal sign. That's another reason for this line, to remind you that you cannot combine positive 5 with positive 25 because they're on opposite sides of the equation. So I'm going to bring down what I see on the left side of the equal sign, and I'm going to combine these like terms. So 25 minus 20 is positive 5. Now, what do you notice on both sides of the equal sign? They're exactly the same, right? So if I tried to cancel out my 5s, I would subtract 5 from both sides and get 0. And then I'd end up with 5w equals 5w, which is the same thing. So as soon as I get the exact same expression on both sides of the equal sign, I can stop. And I know my answer is an infinite number of solutions, which means if I make w equal 1, my equations are going to be equal. If I make w equal 10, they're going to be exactly the same. If I make w equal 100, these two quantities are going to equal each other. That's why there's an infinite number of solutions to number 1. Infinitely many solutions. You can just say it like that. Or in Hawks, it'll have a button and you would just click infinite solutions. All right, let's look at number 2. I'm going to erase number 1. All right, number 2, I have w's on both sides of my equal sign. First thing I'm going to do is draw that line to remind me I cannot combine like terms across an equal sign. So since I have a 2.7w here and a 3.5w on the right side, I want to get those w's together. So in other words, I have to cancel out one of the w's. I either have to cancel out 2.7 or 3.5. And just to be consistent, I always try to cancel out the smallest number. So the only way to get rid of a positive 2.7 is I'm going to subtract 2.7w from both sides of the equal sign, 2.7w. So now that's gone. So I'll bring down my 4.8. And now I'm going to subtract, so 15 minus 7 is 0.8, bring down that decimal, and that would be a 2. So on the right side, I have 4.8 equals 0.8 times w. So I still want w by itself. So how do I get rid of times 1.8? I divide both sides of the equal sign by 0.8. I'm going to get rid of this, because that equals 1. 1 times w is w. And then I'm going to divide 4.8 divided by 0.8, and I get 6. And then if I go back to my original problem and with my calculator, if I multiply 2.7 times 6 plus 2.8, then I'm going to find out that it equals 3.5 times 6, which is 21. So both sides of the equal sign is equal to 21. So I know my answer is right. So always go back and double check those equations. Moving on, let me erase number 2 so you guys can see number 3. All right, so number 3, a lot going on. I see some parentheses, so we know we have to use the distributive property. So first thing I'm going to do is make sure I don't try to combine like terms across the equal sign. Now I'm going to get rid of both sets of parentheses by using the distributive property. Whoops. On both sides of the equal sign, right? All right, so 6 times 4z is 24z. 6 times minus 2, 6 times minus 2 is minus 12. All right, negative 25 times 5 is negative 125. And negative 25 times negative z, you guys have to remember those integer rules. Negative times a negative is a positive. So that's going to equal positive 25z. Negative 25 times negative z is positive 25z. All right, I'm going to bring down that line. Ooh, my pen's all crazy now. All right, so now I have z's on both sides of the equal sign, and I have integers on both sides. So let's go ahead and get our z's together first. Well, I have a 25z and a 24, so I'm going to subtract the smallest z from both sides. Whatever you write on one side of the line, you have to write on the other, remember? All right, so 24z minus 24z is nothing. So I'm going to bring down my negative 12. I'm going to bring down that equal sign. I'm going to bring down negative 125. And then 25z minus 24z is positive 1z. And 1 times z is just z. All right. So now I want z by itself. So how do I get rid of minus 125? I'm going to add 125. Going to add 125, and I've run out of room. But z is equal to, what is that? 113, I think. So 125 minus 12 is, yep, 113. 113. That's what z equals. Ooh, that's a lot of steps. You might need to rewind the video and go through that problem again, okay? But then the last thing you want to make sure you do is check your answer. So in my calculator, I would plug in 113 times 4 minus 2, and then that number times 6. I got 2,700. And then on the right side, I'm going to type in negative 25 times 5 minus 113, and I got 2,700. So even though my answer seems crazy, 113, I know my answer is right because I checked it. All right, let's try another one, number 4. All right, I'm gonna do the work up here so we have more room. So first thing I notice is those parentheses, right? Did you guys see that? So I'm going to bring down 6z plus 7. 6z plus 7 is equal to, I'm going to multiply 6 times z, which is 6z. 6 times 5 is 30 minus 28. Bring down minus 28. So I can combine these two like terms on the right side. So I have 6z plus 7 is equal to 6z. And then 30 minus 28 is positive 2. So now I have z's on both sides of the equal sign. So to get my z's together or cancel out one of them, I'm going to subtract 6z from both sides. Well, let's see what happens. 6z minus 6z is 0. So I have 7 left over here. 6z minus 6z is 0. So I have 2 left on the right side. So now there's nothing else I can do right now except look at this and see what it says. 7 is equal to 2. Is that correct? Is 7 equal to? No, it doesn't. So that means that there is no solution. There is no number I can plug in for z and make this equal, one side equal the other. So basically, if you get to this point and you realize, oh, my variables are the same, but my numbers are different, I can't imagine that these will ever equal each other, and they won't. All right. Now be careful, if one of your variables is positive and one's negative, those don't equal, right? Those aren't the same. But anyway, so just do one line at a time, cancel out what you can, and then see what the final solution is. Hopefully you guys are doing okay with that. All right, so I came up with these 3 other problems. So you guys, if you will pause the video, try these on your own, and then come back and see what you get. That'd be great. All right, so number 5, did you guys use the distributive property? Hopefully you did first. So 4 times x is 4x. 4 times 4 is positive 16. So now we have these, we can combine these like terms. So we have 4x plus 3 is equal to 4x plus, what, 16 minus 13 plus 3. All right, if we continued on and canceled out the 4x's, we'd get 0 on both sides. We'd get 3 equals 3, which is true. So once you find out that you have the exact same equation on both sides of the equal sign, you can stop and you know the answer is an infinite number of solutions. Infinitely many solutions. Hopefully you guys got that. All right, look at number 6. I have an 0.8 m and 2 m. So we got to get those m's together. I'm going to erase number 5 so we don't get all that mixed up. All right, so we're going to cancel out the smallest m. So the smallest m is 0.8. So I'm going to subtract 0.8 m from both sides. Now remember, this is the same as 2.0. And when you subtract decimals, you got to line up those decimals, right? This is like taking 80 cents away from $2. So $2 minus 80 cents is $1.20, right? So this is 1.2 m. Well, I didn't. Oh, sorry. What am I doing? I've lost my mind for a minute. All right, so my 0.8 m's are gone. That's gone. I'm left with 2.4. And I should have written minus 0.8 right here, guys. Forgive me. So this should have been minus 0.8 because everything we write on one side of the equal sign, we have to write on the other. So this is equal to 1.2 m. And now, how do we get rid of 1.2 times m? Well, what is the opposite of multiplying by 1.2? The opposite of multiplying by 1.2 is dividing by 1.2. So we're going to, let me rewrite it real quick. All right, so we're going to divide both sides by 1.2, divided by 1.2, that's gone. 1.2 divided by 1.2 is 1, and 1 times m is m. So then we're simply dividing 2.4 divided by 1.2, and the answer is 2. That's what m equals. And then if you go back to your original equation, plug in 2 for m, you're going to get 4 on this side. When you plug in 2 for m over here, multiply and then add, you're going to also get 4. So the answer is 1 solution. So when you're in HOX, it's going to give you a choice to pick either 1 solution, no solutions, or infinitely many solutions. Once you hit 1 solution, it's going to give you another box and ask you what the solution is. However, if you hit no solution or infinitely many, your problem is over, you got it right, and you move on. Awesome. All right, number 7. I see some parentheses, so we're going to use the distributive property. So on the left, we just bring in what we see. 6 times x is 6x. 6 times 4 is positive 24 minus 22. So we're going to bring down 6x plus 7. We're going to bring down 6x, and then we're going to combine 24 minus 22. 24 minus 22 is positive 2. And then if we try to cancel out our variables, we're going to end up with 7 equals 2. Is that true? Was this the same problem from the previous page? I think it was. Oh, very, very similar. Very similar, wasn't it? Whoopsie. Anyway, it doesn't matter. All right, so does 7 equal 2? No, that's not true. That is not true. So the answer is no solutions. I could not plug in a variable or a value for x to make this equation true. All right, so that was the first section, 2.1a, and you'll find the HOTS examples are very similar to those. All right. Now we're moving on to 2.1b. So we are solving linear equations with one variable with rational expressions. So rational expressions, pretty much we're talking about fractions, right? So let's remember back in school, adding fractions with unlike denominators. So you're not allowed to add or subtract fractions unless they have common denominators. So just a quick recap, we want to think of the least common multiple of 2 and 4. Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, so on and so forth, right? Think of the multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Well, then we go, oh, wait, okay, well, 4 is a multiple of both 2 and 4. So we're going to use the common denominator of a 4. So we're going to use our first fraction, a denominator of 4, and the second one. Well, this one is obviously still a 4. So if the 4 doesn't change, the 1 is not. Now, how do you get from 2 to 4? You multiply by 2. So whatever you multiply the bottom by, you got to multiply the top by. So 2 times 1 is 2. Now the denominators are the same, so I'm allowed to add the numerators, and my denominator stays a 4. So just quick review. Y'all remember all that? All right, now we can also solve equations with fractions. No one likes fractions, right? But when you have an equal sign, you're allowed to cancel out the denominators. So think of our denominators 2 and 5. If we think about their multiples, we would think 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, so on and so forth. And then the multiples of 2, 2, 4, 6, 8, 10. So I see that 10 is the first multiple they both have in common. So that means that I am going to have a denominator of 10. But like I said, if you have an equal sign, you get to cancel out the denominators. So if we use a denominator of 10, I'm actually going to multiply each of my fractions by 10, which is the least common multiple of 2 and 5. So I'm going to multiply this first term, this whole term by 10. This is supposed to be a multiplication symbol. We'll use parentheses. We're going to multiply our second term by 10, and we're going to multiply this term by 10. All right, just bear with me. So if we think about this, we're multiplying 10 over 1 times 2.5. Well, we can simplify 5 and 10. So how many times will 5 go into 10? Well, this becomes a 1, and this becomes a 2, right? If we're thinking of this as a 10, if we're thinking of how many times will 5 go into 10, well, 2 times 5 is 10. So I canceled out my 5, and I'm going to use a 2 on the top. All right, let's go to the next term. So the next term, I'm talking about this. So if I'm using a 10 here, how many times will 2 go into 10? 5 times. And then the last one right here, the last one. All right, how many times will 5 go into 10? 2. So I got rid of all those denominators by multiplying every term by the least common denominator. And that's what it says right here. To clear the denominators, you must find the least common denominator, which we're saying is 10, multiply every term by the least common denominator, okay? So I simplified this way. So now that 10 is now a 2. So 2 times 2 is 4. I'm going to bring down my x. Minus, because there's a minus sign right there. The 2, we've canceled it out. So now I'm multiplying 2 times 5, and I get 5, is equal to, the 5 is gone here, and my 10 became a 2. 3 times 2 is 6. So by multiplying each term by the least common denominator, I canceled out all my denominators. And this worked when you have an equal sign. So now I'm just going to solve my two-step equation like we did at the beginning. First thing we're going to do is get x by itself. Well, how do you get rid of a minus 5? You add 5. So I have 4x is equal to 11. And then 4 times 11. What's the opposite of 4 times 11? We're going to divide both sides by 11. So when you have a fraction that doesn't simplify, just leave it in fraction form. So x is equal to 11/4. X is equal to 11 over 4. All right, so let's try some problems like this, okay? All right, let's look at our denominators 3 and 6. So what would be our least common denominator? Well, 6, the multiples of 6 are 6, 12, 18. The multiples of 3 are 3, 6. So 6 is the first number that both 3 and 6 will go into. So remember what we're going to do? We're going to multiply every term by the least common multiple, the least common denominator. So we're going to take this first term and multiply it by 6. Okay, we're going to take this term right here and multiply it by 6. And then we're going to take this last term and multiply it by 6. All right, so think of this as 3 separate problems for a minute. All right, so if we go this way, we can simplify 6 and 3. We can divide both 6 and 3 by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2, right? So let's do the next one. I can divide both of these numbers by 6. What's 6 divided by 6? 1. 6 divided by 6 is 1. All right, same thing right here. 6 divided by 6 is 1. So everything cancels pretty much. All right, so now I have to distribute this 2 with everything in the parentheses. So 2 times 2y is 4y. 2 times minus 7 is negative 14. And that's why you have to put the parentheses, because you might think, oh, all I'm doing is multiplying 2 times 2y, but you also have to multiply 2 times negative 7 or minus 7. All right, so we have 4y minus 14, and then I see a plus right there. Well, 1 times 12 is 12. Now we have our equal sign. Well, we're multiplying everything by 1, which doesn't change. So 1 times 4y plus 1 is 4y plus 1. All right, our denominators are all gone. So now what can we do now? We can combine like terms. We combine these like terms right there. So we're going to bring down our 4y. Now I'm thinking, what is negative 14 plus 12? Negative 14 plus 12. Negative 14 plus 12 is minus 2. If you're not sure, plug it in your calculator. All right. Now we could cancel out our 4y's. We could subtract 4y from both sides. So what would happen if we cancel out our 4y's? We would end up with negative 2 is equal to 1. Is negative 2 equal to 1? No, that's not true. So we have no solutions. No solutions for number 1. Wow, that's a lot of work, right? All right, let's try the next one. Let me get rid of all this. All right, number 2, look at your denominators. What's the least common multiple of 2 and 4? The least common multiple would be 4. So we're going to multiply every term by 4, by 4, and by 4. All right, let's look at our first term. We're just looking at this right here. All right, what can we divide 2 and 4 by? 2 divided by 2 is 1, and 4 divided by 2 is 2. And now we have to multiply 2 by all of this in just a minute, right? So make sure you put those parentheses. All right, the second one, we're going to get rid of both of those 4s. And then the last one, we're going to get rid of both of those 4s. All right, so now we're going to distribute the 2 to everything in the parentheses. So 2 times 5y is 10y. 2 times minus 4 is minus 8. 14 times 1 is 14. And 10y plus 6 times 1 is 10y plus 6. All right, now what can we do? Now we're going to draw our line. We're going to combine like terms. So I have 10y and then minus 8 or negative 8 plus 14 is positive 6. If you're not sure, plug it in your calculator. Don't guess. Negative 8 plus 14 is 6. And then what do you notice? We have the same thing on both sides of the equal sign. They match perfectly, right? All the signs and all the digits match, which means we have an infinite number of solutions. Infinitely many solutions. And that's the answer, infinitely many. All right, we got a few more to practice. Let's look at number 3. All right, what's our least common multiple of 6 and 3? 6 and 3, we're going to go with 6. So we multiply this by 6, this by 6, and this by 6. All right, so we can divide 6 and 3 both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. All right, next term, we're going to divide 6 and 6 by 6, and we get 1 and 1. And then once again, our 6's cancel, and then we're left with this by times 1. So now we're going to distribute. What is 2 times 3y? 2 times 3y is 6y. 2 times minus 5 is minus 10. I see a plus symbol. We're going to bring down our 13. Equals, and 1 times 6y plus 3 is 6y plus 3. All right, we're going to bring down 6y, and then we can combine like terms. Negative 10 plus 13. Negative 10 plus 13 is positive 3. And then do you notice we have the exact same thing on both sides of the equal sign? So our answer is infinitely many solutions. Number 4. We are going to look at just these two fractions for now because this has a denominator of a 1, right? So what is our least common multiple between 1 and 13? Well, it's 13. So I'm going to, excuse me, I'm going to multiply everything by 13 times 13. All right, so what happens here? Excuse me. Those 13s cancel. So basically we have 4 times z minus 3. All right, what happens here? Our 13s cancel. Ooh, that was ugly. So we have a 53 on top. I didn't mark that out. And then look over here. We're going to multiply negative 5 times 13. Nothing cancels over here, right? All right, so what am I bringing down? I'm going to bring down 4 times z. 4 times minus 3. I see a minus sign right there. My 13's canceled, so I'll bring down my 53. Equals, well, those are just ones on the bottom, right? So I'm just multiplying negative 5 times 13, which is what, 45? Nope, 65. So a negative times a positive is a negative. So that's negative 65. All right, so we're going to bring down our 4z. Now we're combining like terms. So negative 12 plus negative 53. Negative 12 combined with negative 53. If you don't know, put it in your calculator. But that equals negative 65. All right. So now you might think, oh, they match, but they don't. There's no 4z over here. So now we still have to solve for z. So we're going to get z by itself. So we're going to cancel out minus 65. So we're going to add 65 to both sides of the equal sign. So we're going to bring, so this goes away, right? Negative 65 plus 65 goes away. So we're going to bring down our 4z is equal to, well, we have to put something right here. Negative 65 plus 65 is 0. And now I have 4 times z. So what's the opposite of multiplying by 4? I divide both sides of the equal sign by 4. And z is equal to 0 divided by 4. If you're not sure, put it in your calculator. 0 divided by 4 is 0. which is a real answer. So there's only one solution, and that solution is 0. And if you're not sure if it works, then plug it in. So plug in a 0 here, and then multiply 4 over 13 times -3 minus 53 over 13, and it will equal -5. If you aren't sure about what calculator to get, I suggest you get this TI-30XS. This is a great calculator. It's about $12 to $14, Texas Instrument. And the reason I love it is because it has a fraction button right there. It has a pi button we're going to be using. It's just a really good calculator. And you can use this through your college algebra class too. It's got the logarithms and everything else you need, okay? So if you need me to send that information to you, I'll be happy to. All right, moving on. Oh, there's another one. There's number 5. Let me get rid of all this stuff. All right, number 5. I didn't see that one here. So now we're just looking at our denominator. So I see a 7. That's it. And this would be a 1, basically. So our denominator is 7. So we're going to, my dog's in here with me. So we're going to multiply everything times 7. Times 7. And times 7. All right, so let's look at just this right here. Well, I'm just going to simply get rid of these 7s right here. And then I'm going to distribute that 4. All right, the next term, I'm going to get rid of those 7s. Gone. And then over here, past the equal sign, there's nothing I can cancel. So I'm going to distribute the 4 to everything in the parentheses. 4 times W is 4W. 4 times -4 is -16. And then my 7s canceled each other out. So I'm just left with -19 is equal to, and this is just -5 times 7 is -35. So now what do? We can combine like terms, right? These two like terms. So I'm going to do 4W, -16 minus 19, -16 minus 19 is -35. So this is going to be 0 too, isn't it? All right, so now I'm going to add 35 to both sides. So that goes away. I'm left with 4W equals, I have to have a number over here, and -35 plus 35 is 0. 4 times W, I'm going to divide by 4, and 0 divided by 4 is 0. So we have one solution, and that solution is 0. Awesome. Right. Okie dokie. All right, so now the only other thing for this class is our book, college algebra book, study skills. So hopefully most of you have your books by now. So Roman numeral 16, tips for improving math tests. All right, so let's talk about some of the main things. So these are things that you can do to improve for a math test. Avoid cramming right before the test. That means that you need to study along the way. Work through practice problems for the test, review your notes and homework, go to the Student Success Center and talk to your instructor. Now, your Student Success Center is now online, so you guys wouldn't literally go there, but you could definitely get on that, the tutoring site. Some test taking strategies: scan the whole test once you get it. Determine how much time you'll need for each question. Next thing, answer the easy questions first. Some people may think that you should jump to the hard problems and you know, spend more time there, but no, answer the easy questions first. Show your work. So when you check back over your answers the second time before you turn the test in, if you have all your work right in front of you, that'll save you a lot of time. If you're taking too long on one problem, skip it and come back to it. Don't waste all your time on just one problem on the test. After the test, before you hand it in, review your graded test. Oh, so after you've been your test has been graded, but first of all, before you hand it into your teacher or submit it online, just go back over it, okay? It doesn't take that long, and a lot of times you will catch a mistake that way. Once your test has been graded, review your graded test. You will have a final. When possible, correct missed tests if time's allowed, and analyze your errors. Were they careless mistakes? Did I not spend enough time? Was it because I didn't really understand the material? And determine what you should do differently next time. So these are all great tips for improving math test scores. So for your study skills grade, make sure you answer the following 2 questions. Everyone should have a Remind.com account. This is the 3rd set of problems or questions that you're answering. What are some resources that are available to you to help you be successful in your math classes here at Linear Tech? And then what are 2 other things you can think of that will help you be more successful? So you're going to answer those 2 questions and send the answers to me through Remind.com. And so for your homework sections, we've just gone over 2.1a, 2.1b, and 0.3. So if you're in the Tuesday, Thursday class, you need to have these 3 sections done by Friday the 22nd. If you're in the Monday, Wednesday class, you need to have all 3 of these sections completed on HOGS by Monday the 25th. All right, guys, if you need some help or you have some questions, you can always send me an email. You can text me through Remind.com. And also, I'll be live at 6:50. So make sure you go to our meeting through Collaborate. All right, I hope everyone has a great evening. And the rest of the PowerPoint is our next class, the next time that we meet together. You already have my dog is so sad. All right, guys, I'll see you guys later.